Last week you had your mid-semester exams. We are still marking it. So hopefully by next week, your papers should be ready. Okay. Now, and then the week before that, I recorded a video for you, which was on function, writing user-defined function. And the course of recording, I think my microphone was off. So over 30 minutes of the video was just with no audio. So I'll try to recap that portion of the video quickly, and then we can move on to other things. Okay, but uh, basically that session had to do with user-defined functions. Okay, so just give me a moment. Let me open the slides, the lecture notes, and then we can continue from there. All right, so let me just go through the user-defined functions again. Um, I'll work on that video and share it on the platform. Crop that part out and share it with you. So basically, functions are formulas that are written in programs to solve a particular problem or to handle a task. Okay, they are reusable. They are independent of subtasks and so on. Now, in MATLAB, when writing a function, you use this format. Okay, so the format starts with a keyword function. You have the output arguments, that's the values you want to output. Then you have the function name equals the function name, whatever name you give, and then the input arguments. Okay, so then after that, in between the function, you would have the code you want to execute. So the code you want to execute basically is the function that you want to is the formula that you write out as a mathematical expression, okay, inside your code. And then finally you end with the keyword end. Okay. There are times too we use the keyword return if you want to return a value. All right. So I think in the video I went through this part and then talked about the types. Now there are four main examples of um, functions. There are functions that have a single input and a single output. And the example you saw that. So if we take this example here, you can see this function has a single output, which is the volume. And then it also has a single input, which is the radius. Okay, and the function name is the sphere volume. Okay, so basically you are calculating the volume of a sphere. So we introduce the function, we start with the function name, and then we start with the keyword, which is function, and then end with another keyword, function. Then here we have our comments, which showing what the application is about. Okay, just a moment. So here we have the function, the comment. So it says this function calculates the volume of spheres. And then we have here the formula. So the formula volume of sphere is equal to 4/3 times pi r cube. Okay, so the r cube, we've done it r times r times r. So that's how you write a function which has a single input and a single output. Then we come to the next example, which shows us a function with multiple inputs and a single output. So if you're writing function with multiple inputs and single outputs, you can see here, volume here is the output argument, cylinder volume, that's the name of the function. And then you can see the inputs. We have the radius and the height. Okay, so it follows the same syntax. Then you come and write your formula in here as an expression, mathematical expression. So volume equals pi r squared h. Then the next example is a function with a single input and multiple outputs. Now, anytime you have multiple outputs, you introduce the square brackets for the output arguments, as we can see here. So this example is calculating the volume and the surface area of spheres. Okay, so we are calculating surface area and volume. So that means we need two outputs from this particular problem. So we introduce the square bracket right after the function keyword equals then the function name, which is sphere surface area or volume, whichever way you want to capture it. And then you introduce your input argument. In this case, it's R. Are we all following? Hello?
Yes, sir.
Oh, okay. All right. Then we have the final example here, which is taking multiple inputs and multiple outputs. Okay, so it's following the same rule, just like we saw in the previous examples. Yeah. All right. Then in one of our meetings, we looked at this particular question where we computed the velocity of a free-falling bungee jumper. Okay. Now, in this example, we use the square root function, and then we use the tan h function, okay, to do that computation. Now, if you are told to rewrite this particular formula, okay, to recompute this formula as a function tax, then this is how you go about it. So you first identify how many input arguments are in this particular, how many input arguments are available in this formula, and then how many output arguments. As you can see, it's only one output argument. Okay, so anytime you are writing one output argument, you do not need to introduce the square brackets. You do not need to introduce the square brackets. Okay. But if there's more than one output argument, then your square brackets should be there. Okay, so in this example, we have only one output argument. And then we have our values, our input arguments here. We have G, M, C, D, okay, and then T, which are our input arguments, G and M, and then C, D, and then we have T. So in writing the function V is equal to free fall. So the free fall here is the function name. And if you remember from what I said, or if you have read the slides, you notice that the function name is the same name with which you are supposed to save your file. Okay, so the function name is going to be the same name of your file with a save as type as .m. And then you specify the argument. You specify the argument. So in this particular case, I think they omitted the G. I'm sure it's because the value of G is probably a constant value. Okay, it's a constant value. So if it's a constant value, you realize that it has already assigned G is equal to 9.81. Okay, that's the acceleration of gravity. So when writing the formula now as a mathematical expression in MATLAB, it says square root into bracket G times M. So this time it has given us the G. So now the G is not being considered over here as an input argument because the value, the constant value, has already been given to us. So we don't need to put that in our input arguments. Okay. All right. So this explains the function. Okay. So you can see here, the file is saved as freefall.m. And then to invoke that function, we return the command and type in freefall into brackets 12. So what is the 12? Who can tell me? What is the 12 in here? According to the formula or according to the function on top, what is the 12?
Time, sir.
The time, okay. 6.68.1, what is that?
The mass.
The mass. And then the 0.25 is what? What's 0.25?
Second order drag coefficient.
Thank you, Esther. Second order drag coefficient. Okay. So these are the input arguments or input values that we are calling into the function freefall. And then it displays here the answer. Okay. Then this is another example. So suppose the value change. There's a change in value. So now it's giving us a time of 8, a mass of 100, and a second order drag coefficient of 0.25. You realize that's what? When you run that same function, the value changes, okay, due to the changes in here. But the gravity remains the same. Okay. All right. So there are a couple more examples in the slides in your lecture notes. Okay, so read them. All right, so this is the part that I think there's audio was off during my recording. Okay, but I'll just brush through that quickly because they basically are decision-making statements. So once you understand the function and the previous writing codes in MATLAB, this just comes in to help you make decisions. Now, in programming, we call it the control structures, okay, which is looking at the flow of data through your program. Now, if you remember from our first lectures, I made mention of the control structures and the fact that there are three main or three basic ways of writing a program, okay, or solving a problem in computing. The first one is when the problem is sequential. Sequential in the sense that you accept inputs, compute the inputs, and then you display the outputs or print the outputs. Okay, so those problems are straightforward, just like the problems we've been seeing so far, even the ones we saw in the we saw not long ago, to do with some of the shapes and calculating the volume and area and so on. These are straightforward tasks. Okay, so we call them sequential. The approach is sequential, linear in nature. Okay, so we realize we take the inputs, we process them by computing the formula, and then we output the value. Now, there's this other concept, which is branching statement, or what we can also call selection or decision making or conditional statement. Now, there are some times where you have a task which will require that you make some decision, and these decisions are based on the fact that either the problem is true or it is false. Okay, so how do you go about them? In programming, we use what we call decision-making statements to handle them. So for instance, you want to tell whether a student has passed or failed a course. Okay, you can only determine whether a student passed or failed based on the pass mark or the exam score the student obtained at the end of the semester. Okay, so let's say the student read about 5 courses in the semester. We have to add all the grade or the score the student obtained from the 5 courses and then divide by 5. That's finding the average. And after doing that, we have a condition. So the condition can be, okay, if the student obtained a score of 50 or more, okay, the student should be given a pass. But if the score is less than 50, then the student failed. So that is such a tax or such a problem, and it is to be or has to be handled as a conditional statement, okay, or decision-making statement. So there are two main syntax to handle decision-making statements. We have the condition, we have the use of the if with the if-else statement. Okay, so if you look at this syntax here, it says if. So you if, and then you have the condition. So for instance, we say if the exam score, if the score is greater than or equal to 50, that's the condition. Are you all with me?
Yes, sir. Yes, sir.
That's the condition.
Yes, sir. Yes, sir.
Okay. So if this is the condition, then you should print out a statement and say that what the student passed, or you should print pass. Else here means that the student didn't obtain a score greater than or equal to 50. So else you should print a statement fail. You get a syntax. And then finally you end. Okay. So this if, else, and end, they are all considered to be keywords. They are keywords in conditional statements. Okay. So that's one way of handling them. And there can be multiple conditions given the problem. There can be multiple conditions. Okay. So for instance, another example of an expression with multiple condition can be that we want to tell the scheme the class a student obtained. Okay. The class. So you know ATU, we have what? First class, right?
Yeah.
What's the other one? What's the other one?
Second upper.
Second upper. Second class upper. The third one, second class lower. And then what's the fourth one?
Third class.
We have third class. I thought we had pass.
Okay. I don't know.
So let's just assume the third one is pass. And the fourth one is pass. And then finally, let's say fail or rustication or something. Okay. Now, for each of this, we are supposed to make a particular CGPA, meet a particular CGPA in order to gain this. So for instance, first class, your GPA has to be from 4.0 to what? 5.0. Okay. Upper is 3.0 to 3.99. Lower is 2.0 to 2.99. Pass is 1.0 to 1.99. And then fail is you getting less than 1. Are we all here? Are you following? Yes, Benjamin, your hand is up.
Sir, please, it seems your voice is quite low.
Oh, really?
Yes, please.
Oh,
Yes, sir.
hey, the earpiece is closer to my mouth, though. The mouthpiece is.
It's clearer now, sir.
Okay, all right. All right, so with this example here, you can see that there are multiple conditions, unlike the first one where we had just if the student gets above 50 and above, that means the student has passed or failed. Here we have multiple conditions. And this here are the conditions. Okay. This here are the conditions. Before I come back to these relational operators, let me just come down here to explain the conditions. All right. So this syntax here, this syntax is how we represent a problem like this. Okay. So it says if, then you have your logical expression. So logical expression. So this condition here will be used in your logical expression 1. Then if that condition happens to be true, that the student grade point or GPA is between 0 to 5, sorry, is between 4.0 to 5, then that student deserves what? A first class. Okay. Then we have the second condition here, which is 3.0 to 3.9. And that is for the second logical expression. So you notice here a change in the keyword. So the first one starts with if, then the subsequent ones are else if. Now we use else if only when we have other conditions to handle. Okay, so you can tell we have 1, 2, 3, 4, 5. In fact, this one we can even leave it out as else. Okay, but if we have 1, 2, 3, 4. So that means we have to repeat this else if give it another instance here. Okay, to say that the third logical expression will be for 2.0 to 2.9. And then the final one, we introduce another else if before the end, where we handle 1.0 to 1.9. And then finally, we can use the else statement and say the person failed. Okay, so that is how the conditional decision-making statements work, using the if, else if, and else keywords or statements. Okay. Any question? Any question? Okay. So now let me talk briefly about these tables here. We'll look at an example on them before we close. I want to go through the slides first. So we have here, please read the handout. Okay. So we have here a summary of relational operators. Now, these conditional statements or conditional or logical expressions are based on relational operators, or what we also know as the conditional operators. Now, these operators return Boolean value or true or false values. Okay. For instance, the first operator is saying equal to. Now, this equal to is different from the assignment operator we learned in chapter 2. Okay, the assignment operator is different. Now, the equal to, which is the double equal to sign, simply is looking at, we saying our two values. For instance, if we say A equals 6 and B equals 3, is A equal to B? And what would that give us? What would that give us? Hello? Is A equal to B?
Yeah, please, can you come again?
No.
A is 6 and B is 3. And we are saying that relational operators, they give us Boolean values. Boolean values are true or false values. Okay. So if we have here the first example using the equal to operator, and we are saying is A equal to B, where you have A as 6 and B as 3. Is A equal to B? What will be the response? What will be the value?
False.
False.
No. No.
Okay. So that will give us false. Then we come to the next one, not equal to. So you see how that is written. So if we say, is A not equal to B? What will be the answer? Pardon?
True.
That'll give us true. Then this is the greater than or equal to, less than or equal to. Okay, so that's how the relational operations work. So once a statement or a relational or logical expression happens to be true, then it executes the statement under it. But if it is false, it moves to the next statement. Okay. Then we also have the logical operators. Logical operators, as we can see here. The logical operators, we have the AND operator, which is the double ampersand, and then we have the OR operator, and then we have the tidal operator, which is for not. Okay, so anytime we are implementing these operators, the logical operators, we implement them when we have two or more relational expressions. Two or more relational expressions. What do I mean by two or more relational expressions? So if you see here, it's saying L1, L2. Okay, so L1 is one relational expression. L2 is another relational expression. A typical example is this. We have we have A is equal to 6. We have B is equal to 3. And then we have C equals, let's say, let's say 3. Or let me use another number. Let's say 5. Then we have the expression which says A is greater than C. We have another expression, B is less than or equal to C. And then we have our third expression, which says C is equal to A. So what will be the value for A is greater than C? What would that give us?
True.
So that will give us true.
Yes, sir.
Then what about B is less than or equal to C? What would that give us also?
False.
True.
That will also give us true. What about the last one?
False.
That will give us false, because C is not equal to A. Okay, so this is the response we have for the 3 expressions. Okay, now if we want to combine these 3 expressions, we need to use the logical operators. Okay, so the logical operators, we have the AND and the OR. So if I put AND here, and I put OR here, let me use the double. Now, this is the rule. It's saying that for the and, okay, anytime you are using and, that's this column. Anytime you are using and, for your and expression to be true, both expression has to be true for your and to be true. But if one is false, then both expressions are false. Okay, so if you have an expression like we have here, where we have true and true, okay, the first expression is giving us true, the second one is also giving us true, and we use the and here, then that should give us true and true. True and true should give us true. Are you following?
Yes, sir.
Are you following?
Yes, sir.
Yeah. Then let's assume we have another and here. Sorry. Okay. So if this and this is giving us true, okay, then we have this part, the last expression here. So true and false. What would that give us?
False.
That will give us false. Okay, so what it's saying is that anytime you are using the and logical operator, anytime you are using the and, at least, sorry, anytime you are using the and, both expressions or both sides of the expressions have to be true before it can give you a true response. But if one is false and the other is true, or if both are true, then, or if both are false, let me put it that way, then your expression is false. Okay. Now, let's look at an example on the use of the and. Sorry, the use of the or. So let's take the or. And by the way, this is how we write it in MATLAB. Okay, so I'm just following the symbol. That's how we write the symbol in MATLAB. Now with the or, as you can see here, now for your or, at least one expression has to be true for your or to be true. At least one should be true. Okay, so if you have false, false, it's false. If you have false, true, it's true. True, false is true. True, true is true. So at least one of your expressions should have a true value for it to be true. Okay, so now let's come to the right side here. We have our first expression, which is true, and our second expression, which is also true. So if you have true or true, what will be the result?
True.
True or true will give us what? True. Okay. Then here we have false. So true or true will give us true. And here we have our false. So true or false, what would that give us? Based on here,
True.
that would also give us true. You get it?
No, sir.
All right. If you don't get it, please watch the video again to understand it. So it's been explained here. Anytime you are using the or, at least one of your expressions should give you a true. At least one of the expressions should give you a true, like we can see here, for the statement to be true, leading from an or operator. Okay. All right, so let me just demonstrate this quickly in MATLAB so that you can appreciate what we are talking about. So I'll just do it quickly with the in the command window. So we have A to be equal to, what was our value for A? A was 6, right?
6.
And then B was what?
3.
And C was
5.
5.
okay. So our expression, first expression was A is what? Greater than or equal to? Greater than or equal to C, right?
It was B.
It's C. Okay, it's greater than C, rather. Greater than C. So can you see the response? So logical 1. 1 means what? When you see 1, what does it mean?
True.
1 means true. False will be what?
0.
0.
False will be 0. Okay. So we did the first one. A is greater than 1. The answer is logical. Logical is 1, which is true. So if we go into the workspace and I open it, you see there what? Logical, and that is 1. Logical is 1. So this is just the MATLAB help, trying to explain what it means by logical. So logical A is explaining it there. So you can read on it. Read about it and then to understand it better. Then we have our other example, which is B. I think we said the other example is C. C is equal to A. And that gave us what? False. So the false is what? Logical answer here is 0. Are you following?
Yes, sir.
Yes, sir.
So if we want to combine the two expressions, the first one is A is greater than C. And let's use the and. And C is equal to A. Capital A. So that is giving us logical what? 0. That's false. You get it? So from the handout, it's saying that this, when we did this, we had true, which is what? 1. When we did this side, we had false, which is 0. So true and false using the and. The and is saying that both sides has to be true for your and to be true. Okay, so since one side is false, then our and is false, which over here is 0. You get it? All right. So let's try our hands on let's change our and to or. So we change it to or. And that is giving us what? 1. So the OR is saying that if this is true and this is false, the OR is saying that at least one of the sides has to be true. So the left-hand side, which is A greater than C, is true. So once it is true, it's giving us the answer true. Are we clear?
Yes, sir.
Yes, sir.
Okay. All right. So let me quickly move to the next topic. And then once I finish explaining that, I can take an example which captures both topics. Or yes, which captures both topics. All right, so we'll try the example with the marking scheme. Okay, so all this, I just go and read on it. I've explained it. Then we have the nested if statement. So that's if you have an if statement in another if statement, we call it nested. Then we have another example of the decision-making statement. So I mentioned that there's two. There's the if-else and if statements. Then we have also what we call the switch case. Okay. So the switch case. Now the switch case, this is the syntax. This is the syntax. So you take switch and then the expression. So your expression comes here. Now, if the case is based on the expression here, then it's going to implement this one. But if it's not based on that expression here, it moves to the next case to compare. So is this case equal to this switch expression? Case expression 2, is it the same as switch expression? If it's the same, it will implement the statement here. Okay, and so on. So it's just the same decision-making approach, however, a different syntax. We have the if-else syntax, and then we also have the switch case syntax. Okay. Yes, is it Eugene? Your hand is up.
Yes, sir. Please, I think some of us are having a hard time hearing you.
Oh, this one, the microphone, like I keep saying, is close to my mouth. So I'm wondering why
Okay.
it's difficult.
They should check their network.
Yeah, so please check your volume and see if it's low.
Sir, please, my volume is to the maximum. I'm not the only one complaining, so.
But are others hearing me clearly?
Yeah, it goes up and down. So that's a
That's okay. All right. So I'll try and keep it close to
Okay, sir.
close
Thank
to
you
my
very much.
lips. Yeah. All right. You're welcome. Okay. All right. So this is how the switch case also looks. So there are some examples here. You can try them out, but we'll try one before we leave. So you can see with the Bungie example, the free for example again is being introduced here with a function. This time around is using a switch case. Okay, so if the case, the nudging here, so it says MATLAB has a function called nudging function that provides the number of input arguments applied into a function by a user. It can be used in conjunction with decision structures like if or switch. Okay, what we just talked about, if or switch constructs to incorporate default values as well as error messages into your function. The following code illustrates how this can be done for the free for. And this is the free for example. Okay, so with the free for, we saw that he has one output argument, three input arguments, the time, the mass, and the drag coefficient. Then we have the velocity, which is the down velocity v. Okay. So n is the nudging, which has been indicated here. So the case is 0. Okay. So it's saying here that if the case is 0, then what? It should output the error. You must enter the time and velocity. Okay. If the case is 1, you must enter the mass. Sorry, the time and mass. If the case is, you must enter the mass. If the case is 0, if the case is 2, then it means that what CD is equal to this. Okay. And then compute the velocity. Okay. So basically, this is being written as a switch case. Okay. So it's going to compute for the nudging here. If this value is equal to 0, okay, then it's going to tell you to enter the input argument. Now, this nudging here in MATLAB basically means number of the functions input arguments. Are you all with me?
Yes, sir.
Okay. So the number, N for number, ARG for argument, and then in is input. Okay. So it's going to look through your function and check how many input arguments you have here. If it's only one, if there's no input argument, then it will say error. Must enter the time and the mass. Okay. So if it's 0, if the nudging is 0, it will say error, enter the time and mass. If the input argument is only 1, then enter what? The mass. Okay. Now if the input argument is 2, then it will add the CD to it. And if you look over here, the CD, that's the drag coefficient, is given by default is what? 0.27. So it will take the 2 argument, that's the time and the mass, and then use that together with the gravity to compute the velocity. Okay, so the nudging here basically is looking at the number of input arguments that you have entered. And we know that it is 3. However, this is has been given in the problem as a constant value, a default value. Okay, so it's looking for the time and the mass. So if you don't enter the time and the mass, then your nudging will be 0. So it will prompt you enter time and mass. But if you enter only 1, which is the time, it will see it as the time and prompt you to enter the mass. If you enter the mass and the time value, it will now add CD to it and then compute the velocity for you. So that's what this example is looking at. All right, so let's move quickly to the next topic, and then we'll try an example in MATLAB and call it a day. Okay, so the next example here is what we call loops. Chapter 6, loops. Okay, now loops is basically straightforward. What is loops? Loops are the third example when it comes to the control structures. Loops simply talks about repetition of operations. Repetition of operation. So look at what it's talking about here. It says, for instance, you want to calculate the sum of all elements in an array. You have an array of elements, which is from, let's say, 1, 2, 3, 4, 5. You want to calculate the sum of all the elements in your array. What you would do, ideally, will be say what? 1 plus 2 plus 3 plus 4 plus 5. Right? This is what you do. Are you all with me?
Yes, sir.
Okay, so you add it this way. Okay, so what you've done here is what we call the brute force approach. You are going to add it this way. Okay, now imagine you have an array of elements or length or size, maybe 10,000. Are you going to manually, using the brute force approach, be adding plus this all the way to 10,000? This is why you end up using 10 days to complete this. In fact, if it's even exams, you will finish the exams, come back the following day, and you are still doing plus 100, plus 101, plus 102, plus 9,999. You would go on and on. Okay. Now, this is where loops comes in handy, where you, instead of doing this the brute force way, okay, you use a loop to handle this repeatedly. Okay, so he said here, where n is the total number of elements in the array. Another way to write this is to say that what the sum, you initially assign it, sum A, initially assigned it to 0. Then you say sum A plus 1. Okay, so that's to say sum is what? 0. So 0 plus A1, array element 1. That's 1, which will give you what? 1. Then you come to sum again. Now your new value of sum A is now what? 2. Sorry, it's now 1. So 1 plus array at position 2, which is what? 2. Then that will give you sum A will now be 3. Then sum A is equal to sum A plus 3. So sum A, which is now 3, plus array position 3 or element 3, which will give you what? 6. Are you following? Okay, so this is how another way in which you can write this expression. Now, in writing it this way, the second way we just saw, okay, it's also good, but that will also take time, also repetitive. Okay, so how can we write this using a loop without having to repeat be repeating the statement. So here we'll be doing +1 +2, no, or here we'll be doing some +1, some +2. How can we write it that way? So this is the appropriate way to write such a problem. Okay, so first we say that sum is equal to 0. Now if sum is equal to 0, we introduce for II. Now the II here, we call it a counter variable. It's a counter variable. Okay, so here we are saying II for II equals 1 to n. So if your n is, in the first example, our n is what? 5, right? It started from array from 1 to 5. So if it's 5, sum is equal to sum plus a II. The II here is the counter variable. So the II will move from 1 to n, just like we saw in this example. Okay. So once you write it this way, it will loop automatically, repeatedly, iteratively, and then give you your answer. Okay. Instead of doing it +1, +2, +3, using the brute force approach. Now, if your n changes, your array size changes to 10,000, all you need to do is to just replace your n with 10,000. And then this will do the computation for you and repeat the code or repeat the operation 10,000 times with just these 3 or 4 lines of statements. It will repeat it 10,000 times. You get the logic. If you don't get it, we'll try an example right now so that you understand it much better. Okay, so this is what the loops, if we talk about loops, basically it means writing a code to repeat itself. The main thing you need to know is this statement. For I is equal to 1 to n. So always know, if you always know your n, you know how many times the loop will repeat itself. Okay. All right, so this is how the syntax looks like. Then we also have the while loop. Okay, so I won't go much into that. And there are examples here on the use of the for loop. So let's try one example. So you can try all this out. Okay, but I wouldn't go much into it. We want to try the basic. There's also recursion functions, so a function that calls itself, and so on. Okay. So the next thing we'll look at will be on the numerical methods, especially with polynomials. There's a video on the on YouTube. I'll send you that link so that you watch it. Next week we'll meet and talk about using functions in Excel. Okay, that'll be the last topic. I'll skip the input-output file for now and then give you this video to watch. It's one of the lectures I had with the previous class. So you can watch it on polynomials and how to come up with plots given polynomials and algebraic functions, finding plots. Yeah. All right, Elijah, your hand is up.
Good evening, sir.
Yes, good evening.
So you mentioned something that I didn't get it well, and I need a little clarification. The II, you said it's referred to as, is it encounter variable?
No, counter.
Counter.
Count.
Okay.
Yes,
Count.
for counting.
Okay.
So
All
what
right.
you see over there as for I equals 1 to n. You remember this expression from the chapter 2 when you write 1 column 0 10. What does it mean? What does it mean? You remember? We did this in chapter 2. 1, 2, 3, all the way to what? 10. Then we did something like this. If you have column 2, column 10, what does it mean? What would that give us?
2, 4, 6, 8, 10.
No. Look at it carefully. We are
1,
start
3, 5.
1. Yes, thank
1,
you.
3, 5, 7, 10.
Exactly. 5, 7, 9.
9, yeah.
9 plus 2 plus 2.
Yeah. So it's using the same concept, what we learned previously. Now it's saying that the II here is a counter variable, count. So it's just going to do the count. Because you are doing the repetition, it's going to perform the count. So it's to start the count from 1 to what? N. So if your N is 10, it's starting the count from 1 all the way to 10. Are we here?
Yes, sir.
Thank
Okay. So Elijah, I think you get it now, right?
Yes, please. I do.
Yeah.
Thank you.
You're welcome. All right, so let's try an example. My time is almost up. Let's spend the next 10 to 15 minutes to look at the example in MATLAB. So let me create a new script file. And we want to so let me put a comment here and say find the graduating class of a student. So that's what we want to do. So first we can say GPA. To find the graduating class, we want to know the GPA of the student. So GPA, we say input into brackets. So in this example, I'm not using function. I'm just trying to explain the code. Okay, so we'll say enter your GPA. So we expect the person to enter the GPA. Then we say that if GPA is what? What was the range for first class?
4.0 to
1.0 to 5.0.
So
Yeah.
if it's less than or equal to 5, right? Less than or equal to 5. So let's say, so it has to be less than or equal to 5. And so I use the and GPA. So and means both sides, at least one of them must be true. Or GPA is greater than 4.0. 5.0, 4.0. Then what do? We'll say that what? Display. So this display we want to display a string. So we would say display first class. Then we have else if. So else if we come to the next condition. So I'll just copy this same thing and then paste here. So the next condition for second class upper is what? Should be less than or equal to 3.9, right? That's the highest, and it should be greater than 3.0. Please, you get what I'm trying to portray here?
Yes, sir.
Okay. So I'll copy this again for the next condition. So I come to the next line. Next condition, else if, so second class lower, that's what we want to look at. So second class lower is from 2 to what? 2.9. And then the third one, we have what? Pass. Pass is from 1 to 1.1. And then finally, we have else. So with the else, we just want to display. Now, take note, the else doesn't come with a condition. Okay, else means the person didn't meet any of the above conditions. So else what? Fail. And then we end the statement. Oh, sorry. It's less than or equal to. I brought the equal to before the less than symbol. I hope you remember the relational operators from the table. Okay, what we saw in the table. So this is my code. I finished writing it. So we can test it. So I run by saving it. Let me save it as GPA. Illegal name of the script. Okay. So you can't give it a name, the same name as a variable. Please take note of that. You can't give it the same name as a variable. So instead of GPA, I'll say, let me make it CGPA. Or let me say class scheme. And then run the code. So enter the GPA. I hope you can all see that. Enter the GPA. So if I enter 3 points, so you had a GPA of 3.5. What does it say? You see the output.
Second class upper.
Second class upper. So that is here. Okay. So basically, what this saying is the GPA, is that 3.5? Is the 3.5 less than or equal to 3.9? And is that 3.5 greater than 3.0? Logically, that's what is happening. So 3.5, is it less than or equal to 3.9? What's the answer? True, right?
Yes.
Okay. And is 3.5 greater than or equal to 0? 3.0. That's also true.
True.
So true and true will give us true. You see that? So it's giving us what? Second class upper. Now, if we use that same example for, let's say, the first one, which is giving us 3.5 is less than or equal to 5.0. That is true, right? Are you with me? Is 3.5 less than or equal to 5.0? That's true. And
Yes.
then is 3.5 greater than 4.0?
False.
That's false.
False.
So we learned from the operators that anytime you use the AND, both expressions have to be true for your AND to be true. And this is the case, we have one side being false. So that will give us what? False.
False.
Okay. So that's how come it skipped this first condition or logical expression and then executed the second one. Is that clear? So once it's executed the second one and it's true, automatically the subsequent ones will be ignored. These ones will be ignored. Okay. All right. So that's how the conditional expressions or conditional statement or decision statements work. Now let's introduce a loop in here. So imagine the question goes like you want to find the graduating class of let's say 100 students. No, 100 is too much. We'll repeat the code 100 times. Let's say 3 students. When you are trying it on your own, you can use 110,000. That's up to you. But I want to use 3. Okay, so what is happening here is we want to repeat this code 3 times without you having to come and run it 3 times. Okay, so what are we going to do? It's simple. Now take note, you realize that anytime I write the code, I write there's a space, I write there's a space. This is what we call indentation. Okay, so you can see this here, indent. Do you see the top here? Indent. That's what breaks the code in this form. It makes it readable. There are some programming language that if you write them in a straight line and it's not indented, it will give you error. A typical example is Python. If you are writing a program in Python and you don't indent, it will give you an error. Your code will be correct, no error, but because you didn't apply the indentation, you would have error in your code. Okay, so we have to put all this code in a loop. And I demonstrated the loop to you. Okay, so let's try it here. So from line 2 to line 13, all I'll do is introduce a new line and say for I equals 1 to what? 1 to what?
13.
Oh, 3, please.
3.
1 to 3. Okay, so I'll select all this and indent it. So I hit my space bar, indent it, and then put here n. So simple, you can see what I've just done, just 2 lines. I've just introduced from 1 to 3, and then this. Okay, so when I run the code, it's asking me for what? GPA. So I entered the GPA. The student had 2.8. You can see it says what? Second class lower, right? Then it's asking me for GPA again. So I enter for the next student. Let's say 1.5. We are expecting a pass. So it says what? Pass. Then it asks again for the next student. So let's say this student had 4.9. So that's first class. So you realize that after the third instance, the code is off. It's not asking me to enter the GPA again. Because in the loop, we said it should count from what? 1 to 3. And that's exactly what the loop has done. Is that clear?
Yes, sir.
Yeah.
Okay. So basically, in fact, that is what conditional control structures, decision making and loops are about. Decision making, you can have problems that require that you make decisions. Okay, so it may come in different ways. As an engineer, you'll be required to make decisions based on some computation. Let's say you are finding the area of a structure or of a material, and you want to find out if the area is less than a particular value, then you can use that material for that project. Okay, so in that context, you use the conditional or the decision-making control structures with the if-else to determine the area of all the materials you have. So the ones that fall below that particular condition or that particular range, you exclude them from your material. Then you can use the loop to repeat that particular function block of operation over and over again. All right, so that brings us to the end of today's lecture. Let me see if I can locate the video I'm talking about. But I'll send you the link. I'll send you the link. So if you come to the page, the YouTube page, and go to playlists, you go to programming in MATLAB. Sorry, let me go to the playlist. Under the playlist, there's polynomial. There's polynomial. In fact, there's loops and introduction to numerical methods. And there's also polynomials. So I'll send you these two links so that you go over them. And then next week, we'll have our last meeting. And then I'll also talk about the areas you should focus on for the exams. Okay, my time is up. Is there any question? Or you can keep your questions for next week when we have our last meeting after you've gone through the
Please,
videos.
can you get a recording?
Yes. I'll make
Thank
it.
you.
I'll make it available together with last week's recording. I would say last 2 weeks.